Hey guys, Brian here. Welcome back to the shop. Working on a project here today. Getting to do some big boy turning. So I've got out my big boy turning tool measures. This is a Starrett 224 12 to 16 set. Got the hardened and ground screw. The friction wheel on it. This is a good set. I actually picked this up, but this came from the same military auction where I bought my Monarch years ago. I got this set, and I've got the next set up, I think. Now I guess it's let's skip. I think it does says 20 to 24. So I guess I don't have the 16 to 20 set. So if anybody knows one that's not outrageously priced, I wouldn't mind completing out the set. I've got the AA set that I use a lot, which is 0 to 3 or 4. I guess it's 0 to 4. I use it all the time. This is my 0 to 4 set. AA 0 to 4. And there, it doesn't belong there. Don't want to mess my paint up. Yeah, it's those sets 20 to 24. I've got this big piece of bar, or this is actually a piece of cold rolled tubing. You can see the weld seam in it over here. And we got to get this thing bored. I want to do inside and outside to get them concentric with one another and get it cleaned up and get a good round dimension. The dimension itself is not critical because we're going to make the plate that this bolts to. We just got to get it cleaned up, and then once we get it cleaned up, we can make the plate to match. So let's get started. Okay, before I start here, I should probably go over a couple things. People tend to ask me for more thorough explanations of what I'm doing and why I'm doing it. On this part here, since I do want the inside and outside to be concentric, I've decided to chuck the outside first. On the side, it's fairly close to the straightest. So we've got about 30 thousandths run out in this right now, and that's because it is just a rolled and welded together piece, so they're not perfect, especially not over 16 inches. So what I want to do is I'm going to bore this, I'm going to face this outside, get it flat, bore the inside as deep as I can go, but I don't want to go all the way and hit my jaws back there. So there's going to be probably just a little bit of a ring left that's not cleaned up. But what I'll do when I pull this off and put it on the outside of the jaws to turn the outside, it should be really good and true then, because usually my chucks are finna foul or so. I'll need smaller diameters. I'm not sure out here. I don't do a lot of 16 and a half, 17 inch part turning. This pretty good size for the turning work I do on this lathe, although it can swing this no problem. Swings 20 and a half. So when I flip it around and get on the outside, the ledge that's left for me boring the inside will be out here where I can just face it off and clean it up too, and then I'll have a good concentric bore inside and outside all the way through, and that's what we're looking for on this part. That's what we need. So fire up the lathe and get cutting. Alright, let's get that cleaned up. Looking good. So, let's work on this bore. I went in up to my chuck so I could back out till I get a decent line in this that I can see. I'm not real sure how close I'm getting, so that's the safest way to keep from crashing my bar into the chuck jaws. Just work backwards. Tool doesn't cut as good that way, but we're just roughing this out right now anyway. So wear the other edge for a little bit. So changed the plans, didn't quite work out the way I had in mind. So I ended up with my long Williams boring bar in here. In order to be able to reach this, we've got this one of those tool bits that James Kilroy gave me. So we'll put a little quick grind on it. So we've got it in there, and we're working on getting the outside of this turned down. It's coming along. This is about as boring as it gets probably for chip making. I'm turning a whopping 41 RPM, and we're still throwing a blue chip off there at 41 RPM on this high-speed steel, so I don't want to go much faster than that. Put a lot of heat into that tool bit and burn it up. Here on 16, 17 inches of diameter, the surface speed is still pretty decent even at these low RPMs. So we'll let this thing keep munching away at it. I'll sit back and eat potato chips and watch it work. Okay, so here it is. Got it all Nice bored out and outside turned, and we're within 2 thousandths on every dimension on here being square and concentric. There, it's nice and true. So we're ready to get this piece out and put the next piece in and get started on it. Right on where I think I ought to be. See where we're at here. So I've got about 10 to go. Okay, so I got this piece all turned out, and now we got to put some bolt holes and some other dowel holes and things in it. This is some of the hardest AR plate I've ever had to work with. It is nasty stuff. So I'm probably going to run coolant on this to keep from burning up my tools. So that kind of makes a mess all over the camera. I may try and get you up high enough where you can see it. There may just be splashing everywhere and I can't use the camera. In which case I'll have to bring you back when we're done. Nothing too fancy, just some bolt hole circles. So let's get them in there. Okay, so we got the basic bolt pattern drilled in there. Got our dowel holes in. All I gotta do is come through and do these outer ones to bolt this drum on. So I have been using flood coolant on this. So we got a mess here everywhere. So let's cut these holes.